The next library we have is Matplotlib. So Matplotlib is used for visualization of the data, and we can import Matplotlib as import matplotlib dot pyplot as plt. So if you're using PyCharm or anything like that, or if like not a Jupyter or Anaconda, if you're using PyCharm or VS Code, something like that, there are chances that Matplotlib may not be installed in your system. So you'll be needing, you'll be like me, you need to install Matplotlib, and you can do using pip, install pip, and if their errors are coming, so you can look that error up and install it. But by using pip, I think it will be easy, it will be very easy to install Matplotlib if it's not installed. So if no error is coming after running this line, therefore it means that your Matplotlib is installed in your Python. So I'm plotting this simple sine graph. So to plot that, so I'm taking x is equal to, okay, so first I need to import numpy as np. Okay, so x is equal to np. I've told you what linear space do, so I will be doing that into np dot I comma 200. So this where x will have 200 values from 0 to 2 into the pi value. Pi is 3.14, so 2 into 3.14, between 200 values between 0 and 2 into 6. I'll print this x, so you can see starting from 0 till 6.283, these are 200 values. So this is x, and y I have the sign of this, so np dot sign of these values which I have in x. So y will also have 200 values. Now I will plot this. So I can plot like this also, and I can simply plot as plt dot plot x comma y. So value at x-axis goes first, and value to be placed in y-axis goes second. So x comma y, and then plt dot show. So you can see this is the graph of this is a sine curve. So if I want to change the color of this plot, so I can simply write color is equal to, I want to do pink, so color is equal to pink, and it has turned into a pink. If I want to write color is equal to black, so I can write color like this. I can also write color in RGB format, and I can also write color in hexadecimal format. Whatever suits you, it will simply run it. So if I want, this is a straight line. So if I want a dot dot line or dash dash line, so I can change the line into that. So I can have line style, and style is equal to the dash I want. So I can write dash dash, and I will run it. So this line has changed into a dash. So if I want to change this dash line into dash and dot, so I can write dash and dot. So you can see it has changed into dash and dot. And if I want dot dot line, so I need to, okay, so this colon makes a dot 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 line. So this line has been changed into dot dot dot. So this is the line style. Okay, and there is a shortcut also. So what I'll do, I will delete it. Okay, and I will simply write G dash dash. Okay, and let's see what happens. So this line has changed into color G green, and it's now dash dash. Okay, what if I write B dash dash? So it has taken it as a blue and dash dash. So you can see the by default blue color and the blue color here is different. Okay, so this is a short hand notation for writing color and the line space. So, and there, this side is for official documentation. So here you can see all the, I'll click here. Okay, so you can see how to plot, visualize, create, customize visual plot and layouts and other thing. So this is the official documentation. Okay, so next we have, if I have like there was 200 values, so I have this value. Okay, so okay. So I have this value. Now I want to mention, like I have not mentioned anything here. This is by default. So if I want to mention year or temperature, and if I want to add a title, so how should do that? So I will take this graph only. So this is the year, and so I have a list of year and a list for temperature. So I will run this. Okay, so I want to line plot this graph. So I will write plt dot plot, and in bracket I'll write, so whatever I want in x-axis. So I want year in x-axis. So I will change this graph. So in this, the year is in x-axis and temperature is in y-axis. So I will change it. I will write temperature in y-axis. So temp underscore I in y-axis, and year in, sorry, temperature in x-axis and year in y-axis. Okay, and then I want to write, I want to give label to x-axis. So I will write plt dot x label. So this will give label to x-axis, which will be temperature. Now I want to give label to y-axis, plt dot y label, it's year. So I've changed the graph. I've rotated the axis of this graph, and I want to give title to x-axis this graph. So I will write plt dot title global warming. Okay, and then I will write plt. Okay, so what if I skip plt dot show? It's still showing. Okay, and I can write plt dot show. Okay, so nothing matters. But if you're using a very basic because this is an interactive scenario, that's why plt.show does not create a significant difference. But if you're using uh, normal some other Python variation, like Python version like PyCharm or Spider, so you need to mention plt.show, otherwise it will not show the image. So you can see this graph has been rotated. Year is here. So in year 2018 temperature was less, and in 16 it was high, in 17 it was high. So you can see this graph has been rotated. Okay, so okay, then if I want to change the color of this graph, I can simply write either here R. So if this R will work or not, this work. So instead of writing color is equal to red, I can simply write R in quotes. Okay, so now I will plot this graph with multiple values. Okay, so I will copy these values and paste it here. Okay, and then I will simply copy this, and I will change the color. So I want here color is equal to red, and here I want color is equal to green. Okay, and I will run it. So you can see that there is some graph. Okay, you can see graph is there. Customer 1 has red, customer green has yellow, sorry, green, customer 2 has green. But you can only, like, because you can see here, that's why this is for customer 1 and this is for customer 2. Okay, so what if you save this image and show it to somebody? How will that person understand that what this graph is saying? So what we need to do, we need to have something written where that person is able to understand what this graph means. Okay, so what I will do, I will, okay, so for that we have marker and legends. So marker specifies each plotted point, what, like if these point there will be a marker, and legend will help you identify what each plot does. So first I will write label here. Okay, label is equal to customer 1. Okay, and for this I will write comma label is equal to customer 2. Okay, and then I will do plt dot legend. Okay, and run it. So you can see that it's saying that the red line is for customer 1 and the green line is for customer 2. So if you save this graph and show this only this graph to somebody, that person will able to understand. Okay, now what if I want like every point to have like every point is visible? Like when you used to make graph, we used to make a dot, and that dot used to be, and then we used to plot that dot, so that dot used to be visible, like where that dot is and what that means. So what I will do, I will, so that dot thing is known as marker, which identifies each point. So I will write marker. So there are different markers. You can see those markers at the official documentation. But here I want just dot. So I will write O. So I want dot for both the plot. So I will write marker is equal to O. Okay, and run it. So you can see that both the graphs points, both the plot has points in this graph. So this legend can have different placement. Like we can place it here, we can place it here, we can place it here, we can place it here. It can have shadow, it can have font size, different font size. But by default, the legend attribute is auto best, which means it goes for the best placement where it is visible. There is no congestion. Okay, so here we have legend, like different legend values. So I'm putting the location is equal to upper right. So this is the upper right. I can even write, so I will write log is equal to, so for locations log is equal to upper right. I will do upper left. Okay, so by default the placement is best, so it looks for the best placement where this place is empty and it will not cause any issue with the plot. And I will write shadow is equal to true. Okay, comma, font size is equal to large, size is equal to large. Okay, you know what I will do, I will copy this, control A. I will copy this and I will run. So, and why I'm doing this, so that you are able to compare these two graphs. Like I will able to show you this graph comparison. Okay, so show. So you can see that I have put it in upper left corner, and it has this point has now been hidden by this legend, and there is a shadow, and the size of customer 1 has increased. So I will remove this location. So by default it's the best. Okay, so I will keep shadow is equal to true and font size is equal to large. So you can see it went directly to the upper right, and there is a shadow compared to this legend, and the font size is large, like it's bold and large. Okay. Next we have line style. I've told you about line style. So this is the official documentation, and you can see there are different line style: dash for solid, dash single line for solid, dash for dash line, dash dot, and dotted. And we can have none or space, single space, none, none with capital N for draw nothing. Okay, and there are many things, set line with LA, there are many things this, and you can go through all of this. See, set day, color, okay, parameter color, and then cap style, dash style, joint style. So there are many attributes, and there are the description for this. You can visit the official documentation page of the link is given here. Okay, I have even told you about this dotted line, I told you before. Then we have transparency. So if I want to, like, this line is very bold, so if I want a transparent line in one of this, so I can write the attribute is alpha. So the alpha marker, alpha is the use for transparency, and it's between 0 and 1. So 0 means very transparent and 1 means very bold. So I will write comma alpha, alpha, alpha is equal to 0.5, and I will run this. So you can see now this red line, you can compare this red line and this red line. So this red line is now a little bit faded compared to this bold red line. What if I did alpha is equal to 0? So it's gone, it's completely gone. Okay, it's transparent, 100% transparent. So in 0.2 it's slightly visible. So this is, alpha is used to change the transparency of the plot. Okay, then there is a subplot. So what happens in subplot? If I want to show two or more plots in a single graph, okay, like this is a single graph and there is only a one plot. If I want to show two or more plots, okay, like this, okay, so this is a single image, and this is for customer expenditure, and this is for customer, sorry, purchase, and this graph is for customer expenditure, and I want to show it in one line or in one image. So two plot in one graph, so I will use subplot. So first I will copy this. Okay, okay, so why I have written 1 2 3 4 in months? Because if I started writing Jan, Feb, March, it will be utterly congested here, and I need to remove 0 also. Okay, so I'm removing this 0 1 2 0 in front of the single digit so that it is less congested. So if I start writing 0 1 January, February, it will be congested in this small image. Okay, so first is for customer. Okay, so this is for customer purchase. I will write cost E, and this is for customer expenditure. I will write cost E. Okay, and I will run it. Okay, now I want to plot two subplot in a single plot, so I will write, so we have for subplot is row, column, and plot number. So this is row, one row and two columns. So I'm taking one row and two column. Okay, so this is horizontal line. Sorry, this is, yeah, this is a horizontal graph. So I have only one row and two column. So I'm specifying that this graph will be row one. This graph will have one row, two column, and this is the first image. Okay, so plot number, this is the plot number 1. So I will copy this and and then I will copy this. Okay, so this is subplot first row, second one row, two column, and this is plot one, and one row, two column, this is plot two, and I will do plt dot show and run it. So you can see that. Okay, and I have also mentioned X label, Y label, title, X label, Y label, title, X label, Y label, and title, and this is the graph. Okay, you can see that this is been utterly congested. Like the Y label is not visible clearly for this image. So I want to shift this image a little bit to right. So this is the for adjustment. So I want to shift it to a left, sorry, a bit to right, okay, and I will now run it. So you can see it's shifted a bit to right. Okay, what happened if I remove this left completely? Okay, so you can see this has left shift to right. Okay, what if I had written two here and one here? So what would have happened? Okay, so you can see that this graph subplot has been swapped. Okay, so we need to mention like this is if there are four graphs, so I need to write 2 comma 2 1, then 2 comma 2 2, then 2 comma 2 3. I think I have graphs for that also. Okay, so this is for side by side. If I want two graphs on top, like vertically placed, so what will I do? I will switch the number of rows and number of columns. So now I will have two rows and one column, two rows and one column. So I will run this and you can see that this has shifted. Okay, so now again there is this congestion. Okay, so what I will do, I will top top. If I did top 0.1, no, it's showing some error. So top 0.2. So you can see like changing the values is changing the size of the image. Okay, so 0.9. What if I did top is equal to 1? Okay, so I will change 1 to 1.5. So you can see now this image is very clear. It's like you can clearly see. What if I did it to 2.5? Okay, so there is an ample space. This image is now stretched upward. Okay, now right. If I did right one, so now you can see the changing these value is changing the size of this graph plot in this subplot. Okay, next we have, okay, so this plot is for if I want four plot. So I will not show it you. I will show it like how it is done here. I think it's quite understandable. How does this work? Okay. Or I'll do one thing. I will copy this. I will show you for subplot and I will change the size of the image. Okay. First I will run this. So there are four plots. So I told you if I'm having four plots, so I will have two rows, two columns. So 2 comma 2, this is first plot, second plot, this third plot, and this is fourth plot. So now I will Okay, so I will copy this subplot adjustment line and paste it there. Let's see what happens. So you can see this plot has increased in size, and it's now, this plot was so small here, now this plot is big, bit and stretched. So I will change the top to 1.51. Okay, I will change it to 1. Okay, so 1.5. So it's now big compared to this. So this is how you can do the subplot adjustment so that they are not overlapping any information. Then we have scatter plot. So scatter plot, instead of line we have dots, just dots instead of line. So I will run it here. I am copying this. Okay. So what I'm doing, I'm having two scatter. So this will have one scatter and this will create another scatter plot, and though both scatter will be in one plot. So I want to change the color, comma, color is equal to yellow, and this I will let it be to default color, whatever default color it takes. Okay, now I think we can have label also. Label is equal to value 1. Okay, and I can write comma label is equal to value 2 and plt dot. So you can see now a legend is here, which is showing that yellow has value 1 and green depicts value 2. So we can also write label here. Okay, so this further example is showing different colors, and then we can also have each scatter with different color. So number of values, like we have 1 2 3 4 5 6 7 8 10 11 12 13. So I took 13 different values here, and in C it was, instead of writing a single color, I wrote this color array name. So the color was, different colors were here. Okay, then we can also change the size of the scatter. So I will change the size of value to s is equal to 100. To change the size, the size attribute is denoted by s. So I've changed this size of scatter to 100. So you can see that yellow one, the value 1 is small, and even the size at the legend has changed, and the value 1 is small and the value 2 has increased to 100. Then each scatter can have different color also. In the example of size, color. So this was the example of color, like each scatter has different color. Similarly, each scatter can have different sizes. Now we can plot bar graph also using Matplotlib. So I have this month and customer, and I'm plotting this bar graph. Okay, I can change color also, comma, color is equal to purple. So the color has been changed to purple. Okay, then we can have histogram also, which shows the frequency distribution. So I'm using random dot normal. So this give normal distribution. You know about this, how does not this random function works, and I've plotted this normal distribution. So then we can also have scatter plot along with the plot graph. So what is happening in this, I'm generating using X, I've created 60 points, like I want 60 points, and then there is a first distribution and a second distribution. So the x are the first point. uh, so x is 60. This is the time, so it's a minute time, like between 0 to 59. It's a time from 0 minute to 59 minute, and the x is the random distribution. So I'm plotting just a random plot to plot the time of the 40 buses in 1 hour. So what will be the interval for it? So using by first distribution, second distribution, I've taken a value y. I've divided by y makes x. Okay, then we have n. So this is for the time and this is for the distribution. Then I have 40 buses, and then I have bus time is random between 0 to 59 for 40 buses, and bus likelihood is also a random between buses. Then I have made a scatter plot for bus times and bus likelihood, and then I have a plot between this time and the frequency. So this is just a frequency, like high frequency. This is showing that at minute at 15 minute the frequency of bus arrival is high probability, and at minute 28.7 is low, at minute 45 is high. So this plot is showing the relative probability of the high and low of the bus arrival, and these plots are the number of bus arrive at that particular time distribution from 0 to 60 minutes. So this is the explanation of this graph. So I will copy this. I will simply copy this and run it and paste it here, and you can see the graph has been made. So because I'm taking random here, and this, like these values are random, so the dots here has been shifted. Like you can see the dots here and dots here are different because this value is random. What if I run it again? And you can see the dots have again shifted because these values are random. So the bus time and bus likelihood is depending on this random values of 40 buses. Okay, so these are the 40 points and 40 bus. So at this minute you can see like it is relatively near, so it is higher, lower, and higher relative probability of bus arrival. To save the figure, so we need to write plt. So the last figure is always saved. So if I'll write plt dot save fig dot png,